Okay, ferromagnetism. In general, when we speak about magnet, we means ferromagnet. We means ferromagnet. Example of ferromagnet is iron. Example of ferromagnet is iron. When we take a piece of iron and place another piece of iron close to this one, then they will attract each other. Now this attraction is due to the existence of the attraction is due to the existence of permanent magnetic moment. And the material which have permanent magnetic moment is said to be permanent magnet. Permanent magnet. This is one property of ferromagnetism. Now in diamagnetism and diamagnetic material diamagnetic or paramagnetic material magnet, when the B is equal to 0, then magnetization is also equal to 0. B is equal to 0, magnetization M is also 0. But in ferromagnetic material, there is a magnetization. And ferromagnetic material, there is always a net dipole moment, or magnetization. Even in the absence of magnetic field when B is 0. This is another property of ferromagnetic material. Now the third property is ferromagnetic material, FM. Ferromagnetic materials are different from diamagnetic material or diamagnetic material of paramagnetic material in the sense that the atom of ferromagnetic material has a relatively large magnetic dipole moment. This is another property of ferromagnetic material. Now the major contribution to magnetic moment, a magnetic dipole moment, the contribution to magnetic dipole moment is from both spin and orbital motion of electron. electrons. This is another property of ferromagnetic material. Now such behavior, the ferromagnetic behavior or the permanent magnetization behavior is due to incomplete outermost shell of atoms. Like the valence shells of the atom of ferromagnetic materials are incomplete, due to which we have this behavior. Now we will discuss two experimental observation. The first observation is like magnetization in case of ferromagnetic material. Magnetization M increase with external magnetic field B. Now in case of paramagnetic or diamagnetic material, the relation between external field H and magnetization is linear. If we increase the external magnetic field, the magnetization also increase linearly. But in case of ferromagnetic material, if we apply an external magnetic field, the magnetization is non-linear, but its behavior is like this. This behavior we will discuss in the rest of the videos, particularly in hysteresis loop. Now this is one of the experimental observation. The other observation is magnetization M depends on temperature. If we increase the temperature, the magnetization of ferromagnetic material decreases, and at a particular temperature the magnetization becomes zero. At a particular temperature, which we represent by Tc, and this temperature is called critical temperature. At this temperature, above this temperature, this ferromagnetic material behave like dia or paramagnetic material. So if we increase the temperature above this critical temperature, above this value, then the ferromagnetic material will convert to a diamagnetic material or paramagnetic material. We will discuss all these properties in detail in the remaining videos. Hopefully you will understand the concept of ferromagnetism. Thank you.